In today's video I'd like to show you this. It's a USB powered capacitor leakage tester. If you'd like to build yourself a low cost capacitor leakage tester with limitations, then this is the video for you. So let's get into it. This is the majority of the parts that I think I need for this little project. We've got an ABS box, we've got a couple of voltage meters, a power connector, a few 4mm binding posts, some switches, potentiometer, a few resistors, a little module here, a bit of variboard, some standoffs and some connectors. The first thing I really want to do is to figure out how I'm going to mount all of these things inside the box. And to do that I really need to mark the box out and put all the holes in the box so I can mount all these individual parts. I'm going to go ahead and I'm going to mark this out and put the holes in. I won't do that on camera because I have to go into my garage to do that. So when I come back, hopefully that will be done. Okay, I'm back. So the only real issue I've had so far is that the lip of the edge of the box here is so narrow that I didn't actually have room to get the mounting nut for this guy, so I've actually had to super glue that in, so I've done that already. Other than that, I think I have enough space, so I'm going to go ahead and start mounting some of the components inside here. So the first things I'm going to put in are the two yellow terminals on the side. I've actually gone ahead and soldered a couple of wires onto those to make it a little bit easier to put together. Okay. Right, next up I'll do the red and the black ones. So again, I've soldered a couple of wires onto the black ones. So it's not on that one. I think actually we'll replace that for a better quality one. It's obviously not the same quality. All tight. So next, what's next? Let's put the 2 meters in next. So what I do with the meters is I get some of these little standoffs. I have already made a video where I've mounted a couple of meters in a similar enclosure to this. That video I probably showed you how I actually do this, but what I do is I get a couple of the standoffs. I'll just chop them off for the length that I need, so I'm going to go ahead and do that. Okay, we've got the 2 meters, 2 lots of standoffs, some nuts, etc. So we can go ahead and mount these. So I've cut these down just pop those in there, put a little nut on the back to hold those in. Okay, get the first one in. So again, when I'm making these holes, I actually just drill all the way around the circumference, leave a bit of space, then break it off and then just file it out so it fits. It's actually quite straightforward. And again, these little nylon screws, these are all M3. Just have to chop those off. You can literally get a Stanley knife or a utility knife and just literally cut those off. It's very simple. Right, let's find a knife. Okay, so literally just get a knife and literally just cut those off like that. It's quite straightforward, and that's how I do those ones as well. If I can find it. So what I'm going to do is I'm actually going to remove the potentiometer that's actually on this board right now, and then I'm going to replace that with a one that I showed you earlier. Replace that with this one and use one of these cables and 3 terminal JST connectors to put onto the board. So I'm going to go ahead and do that right now. So I've literally just removed the potentiometer that was on this board, put a 3 terminal connector on there, and then literally just soldered the other end of that onto the potentiometer. It's actually quite long, but hopefully it'll fit. If not, I'll just shorten it up afterwards. That's fine. I've also put on a couple of power leads onto here, in and out. So we can put that to one side for a moment. So all we need is the potentiometer right now. Okay, I just put a little notch in there. It doesn't go all the way through. It's just to stop this from spinning when you don't want it to. So we can go ahead and put that in. Okay. So I've got 3 switches to mount here. Now I've gone ahead and put some wires on 2 of them. I'm not sure exactly how the third one's going to be quite yet. So let's just see which ones fit in here the best. So again, I need to put some little notches in these to stop them from rotating, so I'll go ahead and do that. When that's done, I'll be back. Okay, so that's the switches in. Just need to solder some wires onto this one when I know exactly what I'm doing with that one. So last but not least are the LEDs. So I'll just go ahead and prepare those, and then I can get those into. And then the other two LEDs are for the charger, if you like. So we need to put a resistor in series with those. So again, I can just put those in there. Just put a little tiny bit of super glue just to hold them in place. Okay, I've mounted the board in here, and I've made a provision to put a piece of ferro board in the bottom here also. So now I can just go ahead and make all of the connections. Before I do that, I'm just going to solder the other components onto here, the resistors that I need, and then I can go ahead and start joining everything up. Okay, I've got the two resistors mounted, so I can now go ahead and start connecting some of this stuff up, hopefully. I'll see how that works out. So power first. So I've added a couple of power connectors on here. I figured that this would be the least reliable part of the whole thing, so I've made it so it's easy to replace. That's the plan anyway. So here's the finished article. I did actually lose a little bit of footage at the end, unfortunately, just the final bit when I put it together, but sorry about that. I was quite optimistic about fitting all of that into this size case, but it has just about gone in. It's not ideal, but it does fit. So let's just go over some of the connections that we've got here. So on the back side, we've got the USB-C power adapter, which has been super glued in, as I said earlier. We've got the two connections for an ammeter, and then on the top we've got the first switch here, which is a 3-position switch. So in the center position, it enables both the ammeter and the series current limiting resistor. In the down position, it disables the ammeter and the series current limiting resistor, and in the up position it enables the ammeter but disables the series current limiting resistor. The red button here is the test button, so if a capacitor is plugged into the leakage test sockets, these two here, then pressing this button will apply the power to those sockets. When the button is released, then these sockets are disconnected. These sockets are connected to the discharging circuit. The second switch here is a 2-position switch, and in the down position it enables the leakage test, and in the up position it enables the reforming sockets. Now basically, I'll show you in the schematic later, the reforming sockets, if the switch is in the up position, then they have power on, and that's provided through a 33k resistor. That enables you to very slowly charge and reform a capacitor that's plugged into that socket. And then again, as I said, these two sockets are the leakage test sockets. They only have voltage applied to them when you press this button. The knob here is used to adjust the test voltage. Currently this will go up to 38 volts. And lastly, we've got the LEDs. These two LEDs will indicate the capacitor is discharging. So when the LED is illuminated, there is discharge current coming out of the capacitor. There's two because some capacitors are not polarized. So if you have an unpolarized capacitor, you could connect it either way around, in which case the discharge current will be reversed. So we've got two LEDs. One is for forward current and one is for reverse current. And a very similar for the two LEDs for the reforming mode. The red one is for positive direction and the green one is for negative direction. In order for this thing to work, we need a few extra items. Firstly, we need some power. So I have here a USB-C power. It's just plugged into a standard wall power adapter for like a mobile phone, etc. And we can see, I don't know if you can see, no, so I've got a lens here that I can put over to show you guys what's going on. So we can see that the output voltage is shown here, and that will go from around 4.9 volts up to 38.7 at the moment. In addition to that, we need an ammeter. So I've got the approximeter here just to show, to demonstrate. Okay. And the other thing I've made, I've just literally put a couple of crocodile clips onto a couple of 4mm sockets. I've soldered those on, and that way I can plug those two into there, and then I can clip a capacitor's legs into those positions just to make it a bit easier to connect. So we'll start off with a small capacitor. So this is 1000 microfarad, 1500 microfarad, 6.3 volts. Negative side there, so we need to plug that in. Make that a bit easier for myself. Plug that in there. Okay. So this was a 6.3, so we should be able to put this up to 6, just over 6. 6.5 should be okay. So I've got it on 6.5 volts. So we'll start with the this switch in the center position. So that is going to enable both the current meter and the series current limiting resistor. And then this guy we need to put into the down position for the leakage test. Then if I press the go button, that should start to charge this capacitor, hopefully. So we can see that the charge current is initially high. Now as the capacitor is starting to charge up, the current is dropping down, and we just need to wait until it's fully charged and the current has dropped down to its minimum value. So we can see that the current limiting resistor is actually dropping some voltage across it still. So I can at this point push the switch up. That will enable the current meter but take the resistor out of circuit. It seems to have dropped a bit of voltage somewhere along the line. Okay. So the capacitor is now fully charged and we've got a negligible current. I would guess that that's probably around 10 microamps thereabouts. So that capacitor is good. So what we should see now, when I take my finger off the button, that is now going to put the device into discharge mode, and it should automatically discharge this capacitor, and one of the LED indicators should come on to show that. And then we can see the capacitors discharging. And I would say that's probably pretty safe now. Okay, next up, we'll just go up in voltage. So the next one I'll do this is 16 volt 1000 microfarad. So we'll put the test voltage up to 16 volts approximately. Okay, I'll put this back into the center position to re-engage the current limiting resistor. Okay, charge. So we can see it charged up relatively quickly, and again the current's probably around, I would say, 30 microamps at a guess. It's very low, it's acceptable. Let's just push the end switch here to take the series current limiting resistor out of circuit. So we should now get a full charge on that capacitor, and yeah, the current's very low. Again, we'll discharge that one. Discharge is pretty quick. Okay, so next up I've got 1000 microfarad, 63 volts. I think I showed you this in the previous video. So this unit obviously will not go up to 60 volts, but we can put it to its maximum. So we'll put the output voltage to maximum, put the current limiting resistor into circuit and charge. See, the current meter's gone quite hard over. Okay, it's starting to drop. Now it's reaching the voltage. Okay, let's take the resistor out of circuit, finish the charge. Okay, we can see that this capacitor's got a leakage current of probably around 100 plus microamps. Okay, discharge. Okay, so the last thing that I want to show you, I've got a rather large 22,000 microfarad 16 volt capacitor here. So let's put the voltage on to approximately 16 volts. And we can plug that guy in. And we'll put the series current limiting resistor in. So let's charge this guy, and it's going to take quite a long time. In fact, it's going to take ages. So what I can actually do is, rather than sit there with my finger on the button for a long time, I can use the reforming sockets. Okay, so I've got it plugged into reformer socket, so we can see that it's the red LED indicates that it's charging. So once that's charged, the LED should start to dim and go out. Okay, we can see that the current's just starting to drop off a little bit. Okay, I think it's got a decent amount of charging. Let's move that over to the other sockets. Okay, so we can see that's charging. I can take the series resistor out of circuit, finish the charging. So this is 22,000 microfarad 16 volt cap, and it's got a leakage current of, I would say, approximately 200, 250 microamps. This will take a long time to discharge. Right, the last thing I actually want to show you is that I do have here a digital meter. Now this was super high quality, not really, just joking, it's actually a piece of junk. It was practically next to nothing. I think it was maybe £2 or £3. It's a DT830B digital meter. Now I wouldn't use this for anything other than low voltage DC measurement. If you actually look inside this thing, it's quite horrendous. But what it does have is a microamp range. So it's got a 2200 microamp range. Now this is actually quite useful. So I've made up a couple of little test leads here, just with a 4mm plug on each end, and we can actually use this guy as our current meter if we want to go budget and be very accurate. So let's put in the 6.3 1500. Set the voltage to 6-ish. Okay. Let's press the test button so we can see that the meter's gone totally over range as it's charging. And now it's coming back in. So I was thinking it's going to stabilise somewhere around 17, 16, 17 microamps. And we'll just do a slightly larger capacitor. Let's go with this guy. Just let that discharge. See, the discharge LED is on. It's good enough. So I've got this old capacitor back in. We can actually go up to maximum voltage on that one. It's a 63 volt cap. Let's put this onto the 2000 microamp range. Current limiting resistors in, so it's still obviously going to go over. Okay, let's take the resistor out of circuit. I think there's a slight difference in the reading from these 2 meters. I think you can actually calibrate them, so I might need to do that. And we can see it's stabilized at around 90 microamps. Okay. So, hope that's useful. So here's the circuit for the device. It's quite straightforward. We have the USB-C power jack here, and then we've got the boost converter. So the particular one that I used had an output voltage of around 39 volts, but you can use any boost converter that you like. So we've got the 2 voltage meters here, so the supply of those 2 meters are actually connected to the 5 volts coming in, and then the actual measurement side of this one is connected to the output of the boost converter, and then the second meter is connected directly across the terminal for the positive terminal for the leakage test. Switch 1 is actually a double pole, double throw switch. And as I said in the video, currently I'm only using one of the poles and one of the throws to bypass the current meter and the current limiting resistor. What I did actually want to do was to use the second position of this switch to bypass this resistor but leave this one open. So in other words, if I put this switch into the opposite direction, it will remain open here, but the contact will still be closed across the current limiting resistor. That is a mod that I'm going to do after I've finished shooting the video. We can see here that switch 1 is for that purpose. Switch 2 is actually to select which mode you're operating in, so whether it's in the leakage mode or the reforming mode. In position 1, that's in the leakage test mode. The output voltage comes through this switch, through the current limiter resistor, unless it's bypassed. And then this is the test switch, so this is a momentary push button switch. So in its normally closed position, this is the component under test here, J3. In the normally closed position, the device under test will be connected to the discharge circuit. This is the discharge circuit. which is basically a 4K7 resistor with two LEDs biased in opposite directions. I have actually shown an extra set of terminals here. I didn't actually have room to put these, but you could put another set of terminals with a multimeter leads up to the device, and then just simply use this as a discharger, a capacitor discharger. That is another function of the unit that I had intended, but I didn't have space in the particular enclosure that I chose. When the device is under test, so you press the push button switch SW3, that changes the position, so then the device under test gets connected basically to the output voltage through the resistor and the current meter, unless you have them bypass. Then if you move switch 2 to the second position, which is the reforming position, you'll see there's the separate set of terminals here, J2, which is the reforming terminals. And in this case, the output voltage then is passed through a 33k resistor, which charges the capacitor, and across that is another diode. Actually, two diodes, reverse bias, so you can see which way it's charging, should it be a non-polarized capacitor that you've got under test. And that's basically it.